Hello class, this is a video tutorial of functions and function notation. A function is a type of relation. Formally, a function is a relation that associates each number from one set to exactly one number of another set. So here's something that we mean. Let's say we had the x-axis and the y-axis. So we have all the numbers on the x-axis and all the numbers on the y-axis. The following relation is that, by the way, this is what a function will look like, but we'll get more into that later. So if we put 3 into the function relates it to the number 2. If we put 2 into the function, it is related to the number 1 in that function. And I'm sure you get the idea here. So we take one number from the one number set and we associate it to another number in another number set. I want you to take a close look in this one. So far from what we can see, if we have one input, it goes to one output. This is an example of a one-to-one relation, but it's also a function. Here's another example. If we take the numbers 3 or -3 into the function, it goes to the number 9. So 3 goes to number 9, but -3 also goes to number 9. We have 2 going into the function, and it goes out to 4. By the way, here's another example of a function, but we'll get more into the notation later. I hope you get the idea there. One input goes into one output. One input goes to one output. Notice how even though it's two different inputs giving the same output, this is still a many-to-one relation because 3 only goes to one output. So it's that goes input 1, output 1. A different input goes to the same input. That's still a function. This is a many-to-one function. Functions must be one-to-one or many-to-one. You'll see later how if it's a one-to-many or many-to-many, it is no longer a function. Here's an example of not a function. Let's say we have one number set. 3 is associated to 3 and 0. Looking carefully at the lines, 1 is associated to 3 and 1. So the inputs of 3 give two outputs, 3 and 0. So in ordered pairs, we get 3, 3 and 3, 0. So same input goes to two different outputs. That is no longer a function. For the exact same reason, when we input the number 1 into this relation, notice how we didn't call it a function. If we input 1 into the relation, it outputs 3 and 1. So the ordered pairs we get are 1 and 3, 1 and 1. One input, two different outputs. That is no longer a function. Just to clarify, in case you're a bit confused here, all functions are relations, but not all relations are functions. I think that's a point of confusion that many students have. So all functions are relations, not all relations are functions. So let's get a bit more into the function notation. In using functions, there will be a need to interpret the notation used. So the notation that we use for functions is f of some variable equaling the function itself. We can read this as f of x equals 2x minus 1. The letters for the functions doesn't have to be f. I know f seems suitable because function, but it could also just be g of some variable equaling a difference variable. So g squared minus 1. So these are both examples of functions. It could very well have been, we could use h of x, we could have used I of p, we could have used a of t, etc. It's merely just a notation for the function. But the more important notation that we need to understand is the following. We want to calculate f of 2. All this means is we're going to substitute the number 2 into each variable found in the function. So this will become, so looking at our function here, 2 from here, bracket 2, because we're substituting it for x, minus 1. The resulting number for this is 4. If we do it for g of 4, this becomes equals 4 squared minus 1. That's going to be 16 take away 1, which is 15. So simply putting, if you see f of a number or g of a number, just substitute the given value into the pronumerals shown. This, however, f of x equals 0, what this means is we take the function 2x minus 1, or whatever it might be, and we let it equal to 0, or the value that we've been given. And we solve for the pronumeral shown. So solving for this, we get 2x equals 1, x equals half. In the same manner, if we have g of a equaling 8, we take our function a squared minus 1 equals 8, and we solve for a. This will give us a squared equals 9, a equals positive and minus 3. Simple way to interpret this sort of notation, it says what was substituted to give this result, which is what we just did here. We solved for the pronumeral that gave the result 8. So now that we know the notation, and that's plain and simple, the outputs of functions can be sketched on the Cartesian plane, which is just the number plane, by use of this notation. If we let y equals f of x, we get f of x equaling whatever it is. That seems rather confusing, but the main thing you can think of this is that y and f of x can be used interchangeably, but we should understand the difference, especially for later. So think of functions as a number machine sliding along the x-axis and outputs the associated number. So here we have an example of what I mean. Let's take this number machine. We'll place it along the x-axis. If we slide it and it eats up the numbers negative 6, we're putting f of negative 6 now equaling negative 6 plus 1, we get negative 5. So if we take f of negative 6, missed it there. If we take f of negative 6, the function eats it up, and it gives you the result negative 5. But by this notation, we let y equal f of x. So we just say that, we'll just let that become negative 5 there. So there we are. If we slide this along to, let's say, 4, we go back to our function and resubstitute the value of negative 4, which gives us negative 3. And so we just plot it back onto that point there. If we were to do this, the function were to take every single value, it would make a straight line like this. In the exact same manner, we could take a different function, place it along the x-axis, and let it eat all the different values along here. And if we were to graph all of those, we would get a concave down parabola, like so, something or rather like this. Not the most accurate, but I hope you get the idea. So in summary, what is a function? A function is a relation where all inputs have only one output each. An informal test for functions is the vertical line test on graphs. So if you were to take any relation like this and draw a vertical line at any point, I've done it here, and if it cuts the relation at 2 points, or the graph of the relation at 2 points, in this case a and b, it is not a function. Same goes for this one. This is x squared equals negative y squared plus 7. It cuts the graph at 2 points. This is not a function. Another way we can prove this is because we said, going back up here, all inputs have only one output each. If we take a look at negative 2 as our input, negative 2 is giving us two different results for y. So we input x, so let's say this is some function. If we input x, we get two different outputs of, I don't know what that is, what those two values are, a and b. Same goes for this one. If we input the value of x, so 2, so here's our function, or sorry, our relation. If we input 2 into this relation, f of y, because our variables are y, we get two different results, a and b. Hence why these two are not functions. But here are examples of functions here, because now if we do the vertical line test, let me cut this purple line at 1 point. It only hits at exactly 1 point. If I do it here, it only intercepts at 1 point. Same goes for this orange one. It hits exactly only at 1 point. So, hope that gave you a brief insight into functions. And yeah, hope to see you in the next video. Best of luck.